As John Chambers famously said, there are only two types of organizations, those that have been hacked and those that don't know it yet. On the lighter side, the most secure computer is a computer that's off. Today, we have gathered for the technical session on awareness of cybersecurity. Warm greetings to all. I'm Faiza Taskin, 5th semester student from Department of Electricals and Electronics Engineering and student council member of the department. According to the security magazine, there are over 2,200 attacks each day, which breaks down to nearly one cyber attack every 39 seconds. More than 4,100 publicly disclosed data breaches occurred in 2022, equating to approximately 22 billion records being exposed. Cybercrimes cost $2 trillion in damages so far. There's a cyber attack every 39 seconds. A ransomware attack happens every 14 seconds. On average, small businesses spend less than $500 on cybersecurity. Worldwide, spending on cybersecurity is forecast to reach $133.7 billion in 2022. Cybersecurity is the practice of defending computers, servers, mobile devices, electronic systems, networks, and data from malicious attacks. It's also known as information technology security and electronic information security. It is very important that we, as technical graduates, understand the importance of cybersecurity and know how we can offer solutions to face the threats of cybercrimes. With the blessings of the Almighty, I will take this opportunity to begin the event. Be grateful for whoever comes, because each has been sent as a guide from beyond. Now, I request Fatima Sadaf, 3rd semester student, Department of Electricals and Electronics Engineering and Treasurer of Institute Student Council, to welcome the dignitaries.
Warm greetings to all. As Sir Ben Franklin said, an investment in knowledge always pays the best interest. Today, we have gathered to know the threats, opportunities, and challenges in the field of cybersecurity, which is one of the technology of the current and future which has to be addressed. First and foremost, it is my great pleasure to welcome you all and hope that the session will serve as a catalyst for strengthening for transfer of knowledge on the topic to be discussed today. I am honored to welcome an eminent and inspiring entrepreneur, innovator, and a resource person of today's session, Mr. Derek Jose, co-founder and Chief Product Officer, Futura Decision Sciences and Analytics, Houston, Texas area. I extend my warm welcome to Mr. Saravanan Sundaramurthy, CEO and co-founder Exponential Orbit Shifters, Bengaluru, who is collaborating with ATME College of Engineering and setting up cybersecurity in power system labs. I extend my warm welcome to the management of ATME College of Engineering in their absence. I extend my sincere welcome to our beloved principal, Dr. L. Basavaraj, who has been a pillar support in making this institution proud in surge ahead. Thank you for joining and gracing this event, sir. It's a privilege to welcome our beloved head, Dr. Parthasarathi L., HOD, Department of Electrical and Electronics Engineering and the program convener of this event. He is also the principal investigator of cybersecurity in Power System Lab, funded by MODROG. I extend my warm welcome to the event coordinators, Dr. Shakuntala C. and Mr. Srishayana R. and student council members to this event. I also extend my warm welcome to the deans, heads of various departments for this event. Pleasure is mine to extend welcome to all the faculty members, technical staff, and students who have joined us today. Have a great session.
Thank you, Sadaf. Now I request our beloved HOD, Dr. Partha L. of EEE Department to address the gathering. Thank you.
Morning to all. Beloved principal, Arbiters CEO Saravanan, today's resource person, Mr. Derek, police, and my dear students. Today's topic is awareness on cybersecurity, which is a e-buzz today. Wherever you go, this is the word that you come across. And why are we hanging on to this to start with? So there is a motive behind this. We have a strong reason for it. So we are going to initiate ambitious project on cybersecurity. We are starting a cybersecurity lab on our campus. It is a great initiative by our college. We are committed to start this lab because we are being funded by AICTE, which is an acronym of All India. AICTE covers all the engineering colleges in India. They come under government of India. So we are receiving funds to start this cybersecurity lab from government through AIC. It has been told to us and it is being informed by government of India that we need about 3 lakh cyber professionals by the end of 2025. It's a great ambitious expectation by government of India. And today you are aware all our graduates are associated with the cyber. They are vulnerable partners. We need to know how we can really prevent ourselves from that. So that is why government is giving us an opportunity to train youngsters like you in this cyber security. We are going to initiate cyber security internship program on our campus, which is one of its kind. This funding is done to only our college in this region. Ours is the only college which has received this fund from Government of India. From colleges instead will be only our colleges got this fund. So we are going to now ensure that we produce cyber professionals who can cater to the need of expectation. That we are doing. So I want you all to listen to this session and register yourself to that program. So we are going to update our schedule on our official website. You can contact me. So make use of it and to go out with it. We have consulted ISC and we have extra resources to support us to produce this lab. So make use of this opportunity and enroll and have a great day. Thank you.
Thank you, sir, for sharing the information. It's not the resources, but the usefulness that ultimately makes a difference. Now, I request Mr. Derek to take over the chair and give us his insights and thoughts. Now I request Paulina to send us student to the department. And student council member of the department will introduce others first.
Warm greetings to dignitaries on and off the dais. It gives me an immense pleasure to introduce Mr. Derek Jones, co-founder and chief product officer, Futura Digital Sciences and Analytics. Mr. Derek is the co-founder of Futura Digital Sciences, a niche AI and IoT company focused on impacting outcomes for the engineering and energy industries. Futura has been rated by Bloomberg as one of the fastest growing machine intelligence companies, and its AI platform Cerebra has been certified to work with Halliburton and Hitachi platforms. Sir has completed his BTech from BITS Pilani in mechanical engineering. He has served as contributor to Forbes Technology Council, organizing committee, Industrial AI Consortium, East Tech Community, Bloom Ventures. He has also served as a visiting faculty Ashok Gladner Institute of Design at Stanford and currently serving as co-founder Future Decision Services and Analytics. He has also served as the Vice Chairman of IEEE Global Industrial AI Standards Committee. He holds license and certification from Ideas to Action from IDEO. His vast experience is capitalized in future decision sciences and taken it to great heights. We feel very privileged and honored to have you as a person, sir. Once again, I welcome you, sir.
And now I request Mr. Derek to go with us and give us his insights on the topic.
Hello. Namaskar. Very good morning to all of you. All this compromises are very huge experience for me. Not welcome the softest cities in this for us. So what we're going to talk today is so the next 60 minutes, I'm going to gently demystify cybersecurity using storyboards, using some architecture, some library skills, and I will give you a glimpse of the possibilities that exist. Uh, so I will specifically sort of in cybersecurity, I would say there are two broad areas, the continuous kind of things, which most of us are exposed to. But I think the fastest growing side is the industrial side grid security. And I talk specifically about securing the industrial assets and what geography skills that can generate. So before I do that, quick show of hands. How many of you love engineering? Show of hands. Not many hands, okay. Your parents are first to how many of you love crime? So this is an area which is at the intersect of crime and engineering. Now, previous generations we didn't have the luxury of doing something which is at the intersect of crime and crime. But going forward, I think it's going to open up a number of opportunities. So with that, just a couple of stories. So how many of you know about the Stuxnet virus? Stuxnet virus. Okay. Iran was producing nuclear material, and Israel and the US had a choice. They had a choice of putting in bunker busters, which is essentially a plane goes, drops a bomb, goes to the ground, completely destroys the infrastructure. And the other was to introduce what they call as the worm into the nuclear infrastructure itself. So this is the first time they weaponized software, and they introduced a piece of software into the nuclear facilities of Iran. Okay. So they had right somebody in there to insert a USB, and through that USB they insert a worm inside the infrastructure. And what that worm essentially did, the software worm essentially did is, so for the nuclear infrastructure to produce nuclear medicine, that's to rotate in a certain direction. So they changed the direction of rotation and brought on all of the nuclear infrastructure. They didn't have to kill anybody, they didn't have to blast any sites. Very subtly, silently, softly, but effectively, they completely put back Iran's nuclear infrastructure by credits. Okay. That was the first example, and usually one research that is movie made on that. It's a classic case where they completely weaponized software to bring down the capability of the country. The second example of that was, so after 3 or 4 years, so Iran's biggest enemy is Saudi Arabia, which is a big ally of US. Iran got back at US, but not by hitting US policy. They hit where it hurts. They hit the oil infrastructure of Saudi Arabia. Okay. So they introduced a malware into the pipeline, which completely brought down the entire production of Saudi Aramco, the most profitable company on earth, was not producing oil for almost 1 week. Okay. And it was all done again, we counterattack. Not just we written about it in the press because they didn't want to show the possibilities, but it was very real. So Iran got back at Saudi Arabia and they shut down the production. And it's not the consumer side of this. So the industrial side is where it hurts an economy, and you win wars by hurting the economy of another country. Now, if you look at the latest war, which is happening in Ukraine, okay, and there are two key things which have changed from the conventional perspective. The first thing is the extensive use of drones. You don't have to have a human go in an aircraft, expensive aircraft, and all. You send a lot of drones, cheaper, faster, better. And the second thing is attack on the energy infrastructure. Okay, so before the war physically started, that Russia had sent across a lot of these bombs across and got on the energy infrastructure of Ukraine. Today they are using a lot of missiles and drones, but the first attack was actually a digital. So this is the first attack that real takedown of the country's infrastructure was done using drones. And not only those countries, now if you look at India as a country itself, our border areas have slowly started experiencing episodes. I would not say it's mainstream, but they are just doing probing of our infrastructure. So across the border, those guys will send stuff across just to test are our infrastructure secure or not. So those probing is happening at various places, and there are a lot of instances where Chinese hackers have targeted Indian power grid infrastructure. And that's why there's growing need to create. So we are at the beginning of a wave, I would say, where the demand for specifically industrial security professionals will slowly start exploding. You have defense, you have aerospace, you have power sector, manufacturing, silicon, all of this have to get secure. And the amount of budgets which have been set aside is actually nothing. It's like saying I don't have security guards in my every infrastructure has a security guard, right? But it's like saying I don't have security. So all of them have to invest heavily in this in the next 3 to 5 years. And that's the opportunity or the way you guys can run. And I'll give you a personal example of this. So first I want to introduce a particular asset. So this is a robot dog. Okay, and that's what it has. as a cyber talk. Okay. And this is not a science fiction. This is actually being used to inspect industrial assets from an asset health perspective and also from a grid security point of view. So this is something which our company is working on right now. So there's a company called Pan American Energy in Argentina, which is focused on the oil and gas sector, renewable sector, and the conventional grid sector. We just won a project with them along with Boston Dynamics. So Boston Dynamics would send these dogs across to all these distribution transformers in very tough terrains. You can't go there physically, but to go there physically and inspect all those assets is very difficult. So for the current process was very human. Now they're going to let go of a lot of dogs. They're going to have some 30 or 40 dogs run across and watch all of these assets. And the images from that will be fed to the algorithms we have to detect any anomalies for security risks. So the dogs are cameras which will capture the image of the asset itself and I'll give you a glimpse of that. So this is an example, this is something which we're working on actually, which was done in Bangalore, where we got a thermal image of the asset itself, a distribution transformer type of thing. And if there are any spikes in temperature, and that gets detected by the neural network, which Abhishek, one of the engineers, wrote it. We'll also have Abhishek come to talk about this later. But that's the kind of update. This is very cutting edge grid inspection, which has never been done before. 99.9% of the grids do not have the capability to have automatic inspection. And this is one huge opportunity which exists. Again, these are spaces where you can see various. So you take a lot of thermal images. Essentially, the concept is you grab thermal images where a human cannot do using a dog, and you run a neural network which will detect anomalies of interest, areas of interest, objects of interest, events of interest, either from a cybersecurity perspective or from an asset health perspective. So that's the broad application, and this is real. So it's not a science fiction video I showed, but this is actually happening, operationalized, commercially monetized actually. And under the hood of the architecture is we expect gauges. For example, there are analog gauges out there. Okay, and most of the power grid, if you look at it, there are analog gauges, right? And you can't go and change it and make it a digital thing overnight. Okay, one of the cutest application of this is to have a cameraman point at an analog meter, and using algorithms, we can infer the reading and digitize that reading. Okay. So instead of replacing the entire analog infrastructure, you just have an inspection mechanism, and whatever screen grab you get out of that, from that you can digitize the actual readings and put it into your data infrastructure. So that is one thing. Then we look for thermal spikes. So there are various events and objects of interest. The possibilities are endless. Once you have a camera, it can see a lot of things. And then it's got what data lake. And I'm not going to the technical details, but this is something which we cover as a part of the overall thing. The other experience we had as a company was we work extensively in the energy space. And we work with Shell, we work with Halliburton directly on the production grids. Okay. And after they started getting attacked by the Russian hackers, this was about 4 years back, they started getting hacked, the Russian hackers. FBI formed a group called the InfraGuard. InfraGuard is to essentially FBI's division to support all the, to prevent all kinds of attacks on the infrastructure. India still doesn't have it. CPI, all of them do not have this construct, but this is constructed. So, one of the first experiences for us was in the upstream side, oil and gas sector. All the software was either written by Europeans or we were the only ones which are non-European and non-US, which was running on their direct production systems. They actually audited us. So they asked us to be the source code. They went eyeball line by line to see we're not introducing any malicious instructions to their hardware. But we got a glimpse of the possibilities and what processes need to be followed. So going forward, whether it is a lignite corporation, whether it is aerospace, all of them will get regulated. Standard operating procedures will have to be followed when software needs to be deployed, and that's the kind of possibility. In the Indian power grid, I think recently, 21, I think they have released a mandate to prepare guidelines for cybersecurity. And it's under the Ministry of Electronics and Information. It's a nodal agency. Just the umbrella framework has been formed, the nuts and bolts have to be ironed out, and Indian Institute of Science will play a huge role in that, and we already have a collaboration. And they have already broken it down into multiple pieces, thermal infrastructure, hydro, transmission, distribution, renewables, all of this have to get secure. And this is just an early formation stage. So the bottom line is we have a very vulnerable grid. Most countries in the world have a very vulnerable grid. We need essentially a security fabric, exactly like your physical security, all of us need a digital security layer on top of it, which will have multiple components, which I'll talk about in later. And that is a huge opportunity for all of us to create this. And if you look at the grid, the power grid hasn't changed much the last 50, 60 years. It's almost been the same. It is one of the last infrastructure today. Digitalization is very slow. And as it gets modernized, you already started seeing smart meters in the houses. Every time you digitize something, you also increase vulnerabilities into it. It's a double-edged sword. Okay? So, as the degree of digitization increases, the degree of vulnerability also increases. So, as I create new digitization jobs, you'll also create cybersecurity jobs. So, if you look at the grid, the landscape, at a very high level, I think you have power is generated, hydraulic assets, thermal assets, nuclear assets, wind. So there are assets which generate power, then there is transmission, and there is distribution. These are the three broad areas in the power value chain. And this is a very simplified view, but if we go under the hood, many of you would know. I mean, there's a bunch of software which governs the operation of these things. And these were written at a time when grid security was not an actual requirement at all. So all of these are vulnerability points. All of these points which you see, the software-driven operations are all vulnerability points which do not have grid security infrastructure. They're pretty much exposed. And all of these layers would need this opportunity. So when it comes to cybersecurity, there are four broad components in a cybersecurity strategy. You need to prevent it, you need to detect it. If it happens, you need to respond to it and recover from it. Okay. So I'll talk about each of these components. So one is grid attack prevention, right? So today, if a person goes there, you have identity control systems. If you have a substation itself, you have a camera which is watching you, and you can have a piece of neural network run which identifies humans, stray animals, or a malicious intent. Any malicious intent can be detected using the camera with a piece of software on it. And then you have intrusion detection systems on your network itself. You're trying to intrude the network. So the bunch of layers you can start to put on top of it. Next is detection of an attack. So if you are detecting an attack, so there are two types of scenarios. In real time, somebody is trying to poke into your network and do something, alarms go off, somebody looks at it, there's a command center which is there, and responds to it and prevents something from happening. The other aspect is an incident where somebody is included, done stuff, and it's going to happen. Reality is it's going to happen. So like your typical crime scenes investigation, right? Crime cannot be prevented also. After a crime happens, there's a crime scenes investigation. How many of you watch CSI? Seen it on TV. No? CSI, crime scenes investigation. It is very interesting. We were completely focused on DNA forensics to nail criminals. Okay, and then similar to that, the forensic side, once an intrusion has happened, damage has been done, you will need a set of digital forensics team to come in, inspect it, gather evidence, and go back and trace using IP addresses what the origin of the attack was and how did that sequence of events unfold and stuff like that. So there are two broad scenarios. So in this curriculum which we are introducing, we focus on the forensic side of things because, and we have a simulator to show that an event has happened because we can't completely simulate the real-time effect. But once an event has happened, what kind of analysis you want to do on the data to understand the sequence of events and all this. So we'll be putting a lot of focus on the cyber forensics. And that's a wide space today. So there are specialization which needs to be done. Cyber forensics would be a huge area. And once it happens, then the third step in the process is basically incident response. You try to protect the assets and the people once an event has happened. And fourth is incident recovery. So this is a four-step process which normally happens when an attack happens. And so if you look at the criminal side of things, right? So what do cops do? Cops essentially, if you look at it, they're subconsciously doing three things. They are finding out what are all the threats which can happen to a particular area. Which areas are secure, which areas are vulnerable, which areas are not vulnerable, and what is the cost of a vulnerability, right? These are three dimensions which they just bring together to create a risk score of a particular area, right? So similarly, in the grid side also, you will have a matrix of these things. What are the threats which can happen? I'll walk you through some of the threats. How secure is it? Do we have a camera at all? Do we have an IDS at all? What is the kind of so vulnerability is almost as similar to how you put a vaccine for a substation, so to speak. You're not vaccinated, somebody can come and hit you, right? So think of this as a vaccination for this industrial assets. And what happens if you don't have an industrial vaccination? The power could go down, lives could get lost. So you quantitatively you can build a risk model for that, and we go to the details of the future. This one will increase. So as we said, there are two types of scenarios. So if you are going to do a grid forensic, so I'm going to focus in this side on what happens after an event happens. Right? Initially, you're going to have a lot of instances where, let's say, Chinese hackers or Pakistan hackers are going to get into us and bring down something. And how do you go and investigate it? When somebody blasts the bomb, there is a standard operating procedure, right? So the criminals they secure the scene. So this is what is called as 7S of physical security. You will secure the scene. You will separate the witness. You will scan the scene, you will observe the scene directly, sketch the scene, search for evidence, and secure and contact. So these are the 7S standard operating procedure when some, let's say, gun battle breaks out, a bomb goes out, let's say, in India. But the standard operating procedure for cybersecurity is still not done. Okay? And if you have to extend this, I would say for digital forensic, you have to secure the data. You have to collect data from your metering systems, the SCADA systems, access logs. You have to secure the data itself. You have to separate the people. There's the people who have access to the physical side of it, the digital side of it. You have to actually call it out and make sure that you isolate them. You have to scan the data for anomalies. So anomalies could be physics-based anomalies, statistical anomalies, heuristical anomalies, various types of anomalies are there. You have to just scan that. So what do these guys do? They look for anomalies in blood splatter, they look for anomalies in physically. So similar thing you have to do with digital anomaly detection. Then you have to visualize the data, geospatial, box plots, a lot of analytics within this stuff. Instead of sketching the scene, which happens in the physical world, you will do a time series. You will capture the data. Let's say you have data for like 1 year. You will capture the data 30 days before, 30 days after, and capture that as evidence in the secure infrastructure to be produced. And you can search the infrastructure and sort the infrastructure. So this is the standard operating. This procedure has not been defined, and it's an opportunity for you to shape it and drive that conversation along with various agencies like IIC and CERT and all that. So from a technical architecture perspective, so I guess you are electrical students and computer science students. I'll go into a little bit of details under the hood, not much. So you have a lot of moving parts under the hood. You have events of interest, identity management events, SCADA events, smart meter events, all of those. And then you have to triangulate those events. You have to bring all these events to a database, to a detailed architecture. Okay. So if you look at the bottommost layer of it, it is a repository which captures the event. It could be a smart meter application, AMI systems, autonomous metering. In the power generation side, there's SCADA systems which capture time series data, temperature time series, pressure time series, RPM time series, all of that is captured. And then identity management and other business applications, billing data, and utility, all of that. And then you have to extract the data and put it into a central, what we call as a grid 360 data lake. It's a data lake where all the events are poured into it from all across the grid infrastructure. And then you have a set of things to detect patterns out of it. So think of it as input layer where a lot of plumbing happens to build data pipelines from various infrastructure into this data lake. And then you have the pattern detection layer using algorithms. All of it done with the command center. Now, from a research perspective, since I thought there was a lot of interesting research, right? I just thought I'll touch upon a few broad themes where things can evolve from a paper presentation point of view. If you want to write paper, jointly write papers along with ISC. The first is cyber security integrating time series data with vision intelligence. So if you look at the simple, let's say, rotating equipment, which is there in a power generation side. As it rotates, at a basic level, we capture the RPM of the rotating equipment, and which is so that's time series data which is captured, right? And then you have camera pointing at it. It's a thermal camera, you can measure the temperature of the asset itself. It's a normal camera, you can do intrusion detection. But these two data sets, what we call triangulating vision intelligence with signal intelligence, I mean, it's not done much in the problem itself. There's a lot of opportunity to create research and material out at the intersection of vision intelligence and time series. The second area, as I said, is the RoboDog area. Sarvan, we have RoboDogs at IIC, right?
Yeah.
So we already have a RoboDog at IIC. So we asked Professor Jagdish to provide some. You can build a prototype out here where the dog runs around, looks at your distribution transformation, captures the data, and you can run a couple of analytics on it. Now, with one scale, you can deploy it in a cookie cutter manner in all the power stations. It's a huge market to monetize also. You can create startups out of it. A lot of possibilities are endless out there. The third is drone-based security. This most of you know drone is being used for security. Here in IISc, we are doing a project with the Institute of Science on anti-drone, and IISc are a lot of specialists in drone-based inspection also. Perfect place for you to synergize. So we talked about this, robotic clock, and satellite AI also. So today, the bunch of satellites. What's the name of the satellite? Garuda Space. Yeah. So there's this company called Garuda Space, based out of Jayanagar. They today monitor the number of ships going in and out of Chinese ports sitting out of Jayanagar. Okay. And then they work with it. So what they were saying was, Vinay is a close friend, very near ones, that you give the latitude and longitude up to 1 meter resolution, they can see everything from eyes in the sky. Okay. Now this can also be used for grid security, and then we can build use cases. Now all these companies are here in Bangalore, and Sarvan has all the connections. Just connecting the dots and making sure that something good comes out of it. With that, for those of you who are technically inclined, I'll just go into the various kinds of databases. Just touch upon it and not go into details. You have grid security event databases. Any event which happens, the grid has to be captured. IDS, intrusion detection system, logs, identity management systems, SCADA, object identifiers in a camera-based system. And then you have to identify what are the threat events. Just to give you an example, right? A blackout is an event you need to understand. Somebody hacks into your system, you want to record when a blackout happens. The other event which you need to identify is a brownout. A brownout is nothing but somebody is hacking into your system and there is fluctuation in your voltage. It goes up and down a lot, which means somebody is introducing instability into your grid, and brownouts are to be introduced. This happens a lot in India. Last mile power theft. It's still. I was told that Kerala State Electricity Board was saying 18% of the power gets stolen in the last mile. That's a huge number. And they're doing it for the purposes of creating the scene, but somebody with a malicious military intent could use that vulnerability to do stuff. Okay. And there are AI-based algorithms which can detect signatures of last mile theft, and that event can be recorded. And by somebody trying to access, let's say a smart meter application exists, they're trying to try out passwords multiple times so that event gets logged. Intrusion attempts eventually there. Substation, physical attempts to intrude a substation can be detected using cameras and algorithms that needs to be recorded. Denial of service attacks. This happens on the consumer side also. So they set a bunch of servers and found one website so that it goes down. Like this can happen to the power sector also. So most of the attacks which are happening, at least in the Netherlands side, are usually the lightweight attacks. It's basically denial of service attacks. And finally, somebody trying to introduce an innocent USB into it. Even every port has to be monitored, and any blacklisted activity which is happening on the ports should get recorded and all. At a basic level, these 7 events need to be recorded, but there are more events which can be recorded and analyzed. Now we get a little complicated. Okay, I'll not into the full complexity, but I'll give you a glimpse of what can be done once you collect those events. Then you start measuring what is called as the threat vectors. So let's say you have an electrical engineering team that can generate all the events. The computer science AI guys can start converting those events into threat vectors as we call it. I'll give you an example of that. What is the average interval between two blackouts? It's a threat vector. What is the duration of the blackout? Right? It's also a threat vector. So recency, frequency, intensity of these blackouts, all of these metrics are called vectors. So, average blackout interval. And for example, when they are trying to probe the grid infrastructure, they'll just bring down, they'll have a blackout first, then they'll have a second blackout, then they'll have a third blackout. But if you see the interval between these blackouts slowly diminishing, that means it's a low and slow threat. They don't want to alarm you, but at the same time they're probing you. So if shrinkage happens in the blackout interval, then it's a red flag for you to say that somebody is probing your network. It's not the same. So these vectors can give you a glimpse into those possibilities. And today, if you ask me, the Indian government, none of them have the infrastructure to do all of these kinds of analysis. Again, you always have a load profile of consumption. So if you're a typical house, every house will have a load profile of consumption. If you're an industrial setup, if you're a BPO, you consume a lot in the night. Okay. So if you're consuming more than your base profile, that's also not harmful. Right? Something is happening. You've got a cluster inside. Something is happening. Some abnormal activity is happening. You have to double click and investigate that. Then sometimes people attack at night. So what we call the vampire. Vampire is a guzzler of electricity at night. Right? They're not a blood sucker, but they're guzzling a lot of electricity in the night. And you can create these flags in the so again, voltage also, there is the upper control limit and the lower control limit. So these attackers know that anytime you pass out of those bands, alarm will go off. So what they'll do, they'll control it so that we have a lot of fluctuation within that. So what we call is below the radar turbulences. So it doesn't raise an alarm, but there's still turbulence within that infrastructure. You can have algorithms to catch all of this. Loss, attack, leakage. So these are vectors. So a whole science and framework around threat vectors is just not there, and that's an opportunity for research, for actively contributing along with the ISD. And this is a template. I'm just giving you a sample template. You will define each vector, what are the business questions it answers, what are the patterns to look for in the threat vector, what are the affected markers, and what is the algorithm for calculating it. And this has just not been done, and I think there are at least 400 500 vectors which can be created. So each student creates 20 vectors for one period of time. And I think it will lead to a significant amount of research work. The other thing is markers. Markers are nothing but areas of interest in analytical output, for example, a time series. So they could label it. For example, if there's a spike at night, you label it as a vampire. Vampire is the same. It's a guzzler. It consumes more than the average. So these are actually real-world tags which are attached on top of the time series data, so that those high-frequency time series data can be converted into real-world data. That's it. So in terms of what we are going to do specifically for you, we want to do what we call as a crawl, walk, run approach. We didn't want to overload you with a lot of stuff. We're going to start with 5 basic scenarios. So I'll walk you through each of the scenarios as a part of that. One is what we call as grid activity threat matrix. Essentially, it's a bird's eye view of all the vectors across all the regions. We'll develop the screens, and by February first week, we should give you a glimpse of that, of how the screen looks like. The second is watch lists. You always have watch lists, right? In the real world, you have watch lists of people. For example, in the telecom world, there's a watch list of people, and any activity they do strictly monitor, track, and inform and elicit. So in this case, the watch list would consist of all the defense systems. So you'll have the asset IDs in a watch list. And if any event happens to these watch lists, the threat score dramatically goes up. So it could be defense installations, it could be VIP locations, there are a lot of assets around that. Third type of nuclear power stations, border areas, so, high net worth individuals who have a significant say in the economy of the country, the Adanis, the Ambanis, or Saravans. Just kidding. Strategic industries. For example, we are starting to develop chip manufacturing, phone manufacturing, automobile manufacturing, competing against China. And they may have interest in bringing down these infrastructures to show non-reliability to their foreign counterparts. So they have to definitely make sure that these are all protected. Today they're all completely vulnerable. And then the other areas you will start doing a lot of forensics with respect to correlations on the data science side. So basic correlations, I'm not talking about predictions here. So there are three basic types of correlations: positive correlation, negative correlation, no correlation. You will take these threat vectors, mash them up together and find out which are positively correlated, which are negatively correlated, and use that to drive an action. And these are some of the initial vectors which will be there as a part of the software: brownout frequency, blackout duration, intra-blackout intervals and stuff. Man movement of the count. All of this will be there as a part of the initial software which will be there. And the fourth thing is vector diagnostic. Vector diagnostic is nothing but it's kind of like your blood test. Okay. So let's say an asset went down. Okay. It's like an asset which is unhealthy. Right. So you're going to the doctor. You guys are the doctors. You'll run a battery of tests to see did it pass this diagnostic, this is pass this diagnostic. So there are 7 or 8 diagnostics, and then you color code it red, yellow, green. Okay. So it's almost like you need grid doctors, so to speak. And when an asset goes down, you run a battery of tests. So you have one scenario around what are the standard tests you need to do when a grid asset goes down. Okay. And how do you interpret that, how do you act on that in one scenario based on that. And the output will be almost similar to the blood test report. You know, the test name, what is the expected range, what is the actual range, and this is red, yellow, green. And then we have, and this is probably the most important thing, some of the smartest hackers will not leave any bigger footprint, right? They will not leave any digital footprint. So the standard set of signatures which you apply after an attack happens, you will not find evidence. And in this case, you have to go to the next level and start digging deeper. So you'll have to go into very raw data files and start what we call as looking for a needle in a haystack. Okay, you're looking for a small thing which has happened somewhere. So you have billions of events, data points in your data lake. You're looking for one data point which actually says this is the beginning of the grid breakout event. So you have a scenario around looking for what we call as a needle in a haystack. So if all of the signatures fail, you still can't find evidence. You resort to this to go and inspect areas of interest digitally. This is like looking at carrying your lens and examining each piece, each thing, to have small traces of fragments and stuff like that. And we'll be introducing this also. We are using an IDS called SNOT. Any of you use SNOT here? Intrusion Detection System? Computer science? Okay. So probably as a part of this, we'll teach you how to install SNOT and use SNOT. It's an open source, you don't need to pay for it, but the event logs are of interest. And the other thing which we can probably shape is this is something which we can do by sitting with IICs to create what are the job ready skills for cybersecurity. Cybersecurity is still a broad name, it's like saying engineering, right? You need to go into the details there, right? So what are the job ready skills for protecting the industrial grid? It could be, for example, initial list is you need a command center monitor, you need a smart meter specialist, you need a SCADA specialist, you need a grid network security specialist, forensics analyst. So the initial set taxonomy around what are the kinds of people who will come together when an event happens. So for example, if a real world event happens, there is a guy who specializes in chemicals, there's a guy who specializes in blood splatter, there's a guy who specializes in hair who comes in all together, right? It's not a generic forensics guy who comes in, it's a super specialized guy who comes in the set of tools. So you have a similar situation here. You need super specialists in forensics, and those job skills are not being realized. So Professor Jagdish will help us train this and also put it in front of the right authorities at CERT and all of that, so that you can co-create that. It's not that your followers are actually shaping this whole process. And there are a bunch of standards for those of you interested. These standards are still shaping. These are still not granular yet to be actionable. These are high-level frameworks, but I think in the next 1 or 2 years they'll really get granular and actionable. And one of the most important things will be a digital reliability engineer, electrical reliability engineer, who ensures the reliability of a grid infrastructure. You'll have to create a digital twin of every asset, right? Substation, house, solar power units, everything will have to have a carbon copy in the digital world. Right? You have a physical copy and you have to have a digital copy. So you need to have a digital twin process, and then you have to do diagnostics, prognostics, on. So there is a whole set of job descriptions around what tasks need to be done. These tasks are not being done today, and that's where the opportunity arises. Uh, and most of the people are grey-haired people. They're not youngsters like you folks, so they're not very savvy digitally. So it's an opportunity for you to digitally skill them. And these are just templates for you to say what are the various kinds of tasks, and these are templates we populate as we go along. So in a nutshell, I just come to the end of it. Basically, there are two types of scenarios. So if you've forgotten everything, just remember the five things. Okay. First is you have real-time threats to prevent it. The second is you do the forensics part. There are three types of grid assets. You have the power generation assets, the distribution assets, and transmission assets. All the three types of assets need to be covered. And in the forensics world, there are two important things you need to introduce two important terms, what are called threat vectors. So that needs to be actively, these are metrics which give you a signal as to some malicious intent of an actor. So threat vectors are important. Threat markers. Threat markers are labels which you attach on top of the time series data. And most important, this is a very lucrative space. There's a lot of money to be made by startups in terms of jobs. If you want to go abroad for masters, anything you do in this area will be gold. From all that, from job, startups, so going abroad perspective. It's a complete wide space. As Professor said, there's a lot of money being spent on it, and you'll see an exponential explosion in interest as well as investments which go into this. And you guys are just starting to take the first step. Thank you for having me, and wish you all the best. Any questions?
Like how is the government dealing with?
So, so today, there are two things. Once an incident happens, there is a group called CERT, Incident Response Team out there. There are standard templates and processes to be followed. This is primarily from the consumer side of this. Okay. The process should not measure for him. So CERT will become the node agency which will disseminate standards and respond to it at a high level. But I think at an investment level, let's say private companies will have to spend, like your security guards, right? So there's an umbrella body which says, these are the standards to follow. Then you have to spend money on IDS infrastructure, for instance. So both levels, standards, investments, and processes have to be defined. It's still not.
Question: as a beginner, is there any prerequisites to learn?
I have a point of view. I don't think any prerequisite as long as the person has fire in the belly. That's my point of view. So I don't know if it's the right answer, but that's what I strongly believe in. So fire in the belly. No, any branch can do it, but see, ideally, I think it's a interdisciplinary skill between AI and electrical, uh, and then and I think AI is going to be bread and butter for all disciplines. I think any discipline will have to have the Sarigama Padis and going to be AI going forward. So I think these basics of AI will be taught across disciplines, and if you have an interest in that aspect,
What is the black hat and white hat certification?
black hat and
White
white hat verification. Certainly, I don't know that.
hat. Support cybersecurity.
I come from the industrial side. I have consumer side. I think there are a lot of things which exist. Industrial side, I have not seen certification program which exists.
Sir, actually your presentation was very well done. I have a couple of questions, sir. In 2012, India had can you explain what was the major thing that has happened on that day? Blackout. In India, as for one day, have you come across this?
Blackout.
Any particular reason?
You are asking about that specific
Yeah, yeah,
one?
specific. Yeah.
Specific instance, I don't have, I don't know what exactly. You want to know the root cause for that event?
Whether it might be a security threat or any generic.
It could be a malicious intent. I really don't know the details. Yeah, that part of it. I don't know. Yeah. You are asking about that specific event, what happened? I don't know.
One more thing, actually, GDP is around 8.5 for energy sector, which has been proposed for 2023. And where we stand with respect to cyber security threats, in particular for grid or energy, compared to US, which is having 70%, 17 of power consumption. Whether we are lagging behind or in phase. Okay.
So your question is, where do our investments in grid security stand vis-a-vis the US, right? See, we are still, the US is a heavily attacked country, okay? So they have a lot of enemies. We do not have that many enemies, okay? But we have started getting it in the last 2 years. Okay? So my feeling is our investment is any company. Let's say if you take Bestcom, you ask them for every $100, let's say $100 is the budget. How much they spend? They spend less than 10 cents on cybersecurity. Less than 10 cents. I mean, there's hardly anything awareness about it, but that sensitivity around it is heightened. In my opinion, you need to spend minimum of 8 to 12% of your money on protecting your grid. Okay. Because kind of threats which are going to come can kill people, can completely bring down the economy. So, so it's like climbing from 10, 15 cents to 8 to $10. So it's a big headroom you got there. US has been heavily attacked, so DARPA, all of them have been spending billions of dollars in protecting it because it's still insecure, primarily because the software which is done, the SCADA system, the Siemens software which is running, it was written almost 40 years back. Okay. How do you go and protect SCADA software which is written in that time? So they had to go and retrofit all of this. There's still no answer. So that is one of the reasons after the attacks came. This is very interesting pattern. Many of the grids have said, I don't want to do threats. I'm fine without being digitalization. Because the threats are more than the advantages of it. Right? So, so it's going to be interesting, the dynamic which plays out. Okay. There are advantages to digitization, but if there are vulnerability, the management is going to say, the vulnerabilities are more than the gains. They're going to say that I'm better off not paying threats. But that dynamic is going to play out, which means you need to up your ante on investments. And really have investments. It's like saying I will not have a security guard. Who says that? Like today's world. Even a small particular company will have security guard standing in a uniform. ATM guy has a uniform. Right? There's a camera, one guy is standing there. Okay. So in your ATM has a security guard, many of these big assets do not have. And that's all. And most of it is digital. You can't have physical. Digital. So in terms of investments today, very big pathetic. But has the government started actively working? Yes, they realized it that they have to spend as much on grid security as much they do on army, air force, and navy. That's the realization. Because Ukraine war has shown that. Because you just send bombs across and you can do as much damage as an F-16 or in fact more, damage. So they're taking this pretty seriously, and you'll see the same kind of investments in industrial grid security. I don't know what consumer side, industrial grid security, as much as they give to the army, navy, air force, nuclear submarines. That kind of this thing is coming. And they're also set up units, grid security units within the army, air force, and all that. And that's the biggest opportunity. And they're all made inputs on forensics and all of that. They don't have it. So this is a perfect place where academia and the industry and startups can collaborate and add value. There's money to be made. They give you the money. Money will be the easiest thing to get. I think the capability has to do it.
Any questions?
Is there any classification of cybersecurity in terms of online and offline?
Yeah. So if you look at the threat types, one is as I said, real time. You can focus Scala system and make it turn in a different direction. The other is what they call as low and slow threats. It's offline. Okay. So the guy wants to get past the security layer, but he will not do. He will just go and sleep there. He'll just sleep there for a long time because he say, okay, I'm not alarmed. Then he'll go to the next computer and sleep there for a long time. So that's a slow offline. He will not pop his head up suddenly. So he'll replicate himself, and at one point in time, simultaneously explode. So that's the offline nature of it. There are two types of things. One is immediate instant attack, real-time attack on the grid, everything comes down. The other is what we call the low and slow, below the radar effects. That harmlessly you don't want suddenly, it's what the Israelis call as the insider sense, right? So it's the inside unit. So if you look at those of you interested, it's almost similar to what happens in the Palestinian. So what happens is Israel develops people who at a very young age go and enter the Palestinian system, and you see this series called Fawda, you see that. They grow up and then they start feeding information back to Israel. Similarly, the other thing may also happen. You have Palestinians who are embedded in the Israeli system who grow up and improve. So similar things are being done in the digital space itself. You are injected into the system, you live there, breathe there, and when the time comes, you activate. And that's the offline.
Is there any protection that has been because in the offline part, you would be able to access it. That is what the major difficulty what we are having. In the online, yes, every time we are in a connectivity so that anytime from any part of the world we can activate it, a daily movement. But what happens to the offline?
Okay. I'll answer a question by looking at what happens in the medical field and the fraud field. Right? So you can say a virus comes in the medical field. Right? How do people detect it? Because the virus leaves behind a signature, right? And that signature is detectable. So today you have databases of virus libraries, signature libraries, right? Earlier it was small and slowly the virus library starts increasing. But still there are ways by which there are new viruses getting injected into it. And a similar concept needs to happen out here. You need to have a set of grid signature libraries. So the grid signature database is literally 0 to 8. Yeah? You start developing it over a period of time. And the key to it is signature based detection. Whether it's medical, even in fraud, if you go to the bank, fraud analytic systems, if you look at it, they have a library of signatures. If you match this pattern, you're a fraud. Right? So that's a pattern detection. So you will have to develop the sense and response systems for this, where you sense a pattern and continuously keep updating your signature library.
Any questions from the audience side? your vast information with us. I hope that today's session has given rich knowledge and hope the young upcoming graduates will serve for the need of the society to face cybercrimes. Now I request Karthik, 5th semester Triple E department and student council member of the department to render vote of thanks.
Morning to dignitaries on and off layers. ATME College of Engineering, Mysuru has emerged as a prominent institute offering quality engineering education. It is a great initiative by the Department of Electrical and Electronics Engineering to organize the technical talk and bring awareness on cyber security. On the behalf of ATME College of Engineering, I extended my sincere gratitude and thank Mr. Derek Jones, co-founder and chief product officer, Futura Decision Sciences and Analytics for accepting our invitation on resource as a resource person. Thank you, sir. I thank Mr. Saravanan, CEO and founder, ex-Orbit Shifters, Bangalore for joining this event. Thank you, sir. I thank the management of ATM College of Engineering for encouraging and supporting in the conduction of this event in their absence. I extend my gratitude and thank our beloved principal, Dr. L. Basavaraj, who has been the backbone in making this event a grand success in his absence. I extend my profound gratitude and thank Dr. Parthasarathy L. HOD, Department of Electrical and Electronics Engineering for organizing this event. Thank you, sir. I thank the event coordinators Dr. Shakuntala C. and Mr. Shishaina R. for the smooth conduction of this event. Thank you, sir. I thank the deans, HODs of all departments for the supporting for this conduction of this event. Thank you all. I thank the faculty members from various departments, student council members, technical staff, volunteers for supporting this event. Thank you all. Have a great day.
Thank you, Karthik. Thank you one and all present here to make it a great success. I would like to conclude this event with a quote. For every lock, there is someone out there trying to pick it or break it.